not reflecting, right? That's good. Dektak 3ST surface profiler, originally made by Veeco. This system is run using a PC with Windows 98 operating system on it. And the system is connected to the unit through an interface port installed inside the PC. The application software pops up as soon as the system is powered up, and once enabled, it's possible to control the system from the optical mouse, which is connected to the serial port on the personal computer. It's not a regular mouse. The menu items include the scan programs. We can have mini scan programs, multiple scan programs to be performed to profile at different lengths. But the stage is manual stage, so in order to be able to do multiple runs, you can only do in one place, and the stage has to be moved manually. Here's the screen for the scan routine, where the scan ID, which is the information for the recipe to run, the scan length, it could be microns, a maximum up to 5 millimeters. The scan length, the scan speed can be adjusted, low, medium, and high, and also the data resolution, low, medium, high. Based on the selection of these speed and data resolution, the data points will be collected. For high resolution, more number of data points. And the stylus force is adjustable from here. You can select anywhere between 5 milligrams to 35 milligrams. The details are explained in the manual. The profile could be three kinds, a step up profile or a step down, or both, step up and down. And at the end of scanning, the system could be programmed to do the leveling as well. And the right or cursor stand for right cursor, and M for the measurement cursor. The location of the cursor could be selected. And there are more options available for data processing. So the run mode, to start the scanning, we have to click on run. And in display mode, we have various displays available: video, graphic, video and graphic. Also display the sample positioning. Program summary and data plot also can be viewed. You can save the video image if necessary. Now here is stylus up down. Soon after connecting the system, if we click on stylus down, you can see the video image. And adjusting this knob on the profiler, we can focus the pattern on the wafer, and the reticle should match the image. If not, the reticle alignment can be done. And there are knobs on the stage. The knob here is for moving the stage in x-axis direction, but the video image moves vertically. And this is for positioning it in y-axis. And this big dial at the bottom of the stage is for adjusting the tilt of the stage itself. The stage is driven by a variable speed adjustment motor. The motor is connected to the stage through a gear assembly and clutch mechanism. The intensity of the lamp can be adjusted to get a proper illumination of the pattern or the wafer surface. In the print menu, there are plot and summary can be printed, or only plot could be printed, or summary only. And we can also print routine form and multi-scan forms. In the setup menu, we have a screen for vertical calibration to calibrate the profiler, and the stylus reticle alignment, and also printer assignment. This system is hooked up currently to an OmniPrint 426 thermal printer. And if there is an external printer which could be connected to the line printer on the PC, the option is available to hook up to the external printer. But before selecting this, the proper drivers are to be installed on the PC. I'll quickly show how to do the reticle alignment here. So you select Align, and we should have a substrate on the stage before doing this. So the system prompts for that. Click on OK. Now the tower is coming down. At the status bar down here, it will indicate what the unit is doing. As it comes down, we can see. Also, there is a manually zoom adjustment is possible here using this. And the final lens, the focus lens, could be adjusted if necessary. There is no motorized zoom on this machine. Now once you see the shadow of the stylus tip and the image of the stylus, double click on the right button on the mouse, and once it is set, then we can align and using the second button here, we can update the feature alignment reticle. So this is the video and graphics display. You can have only graphics. Right now there are no graphics because once we scan it, then the graphics data will be available. Let us run a single scan. So the tower is coming down at this moment. And there is a time delay for starting the scanning, and at this moment the scanning is just initialized. We can see the trace while it is scanning. These are the reference and measurement bars. The unit already leveled it, and we can also select the window and replot it. So this is the selected portion replotted if necessary. And now by selecting the reference cursor, I can bring it to the left of the step, and measurement cursor in the step area. Now here it is showing the vertical distance of this 10 kiloangstroms step height. We can select the analytical function and measure the average step height. So the values are computed and are displayed. The bands menu will allow us to select the bandwidth and enter the default bandwidth, enter the software leveling options. But there are several analytical functions available on this unit. The roughness parameters can be selected, the height values can be selected, the waviness and the geometry also could be measured. Also, there are smoothing and cutoff filters available. So we had to select the smoothing degree and smoothing bands. And the data could be loaded and saved in the data menu. So I'm going to print this, both plot and summary. There's a DC power supply in this upper shelf area where the power line is connected, and the DC power is fed to the profiler using this 9-pin connector. Here's a 37-pin connector. This is the main connector that goes to the interface port on the computer, and the video from the camera is attached to this interface AVI interface module on the yellow connector, and the mouse is attached to the serial port number 1, and the printer is attached to the parallel port, the line printer here, and the 17-pin video graphics connector is the usual one. And never a regular mouse should be attached to this unit. The software is designed in such a way only a 9-pin serial mouse is to be used on this unit. So never put any regular mouse on this unit. So here is a printout displaying the graphics and the data plot. The left hand side module, this is the illuminator for illuminating the sample surface. I'm just sliding out the sample. And this arm on the right hand side is the microscope attached to a camera inside. The stylus arm will move as we lift up the microscope boom using the knob in the front. Now I'm going to show how to disconnect the stage from the coupling and remove it. And this plastic cover here should never come out. It will be shipped with this cover in place, and for running the unit this should never be taken out. You need a flat blade screwdriver, and there is a screw deep in here. To decouple it, rotate the screw clockwise and the gear arm on the stage will be decoupled. Now once it is out, lift the stage from the front and slide it out. So while installing the stage, make sure these two clamps are slightly pressed against the left surface on the glass slab here. And once it is in, slide it in and latch it using this screw by rotating it counterclockwise. So for shipping purposes, this surface is usually protected from any kind of particles. And also this flag is installed in order for the stylus not to bounce around. So this will restrict the movement of the stylus. At the time of installation, just detach the tape and pull the flag off.